So let's get to the results section. How was your reading of the results section? Did you understand heads from tail or not really? I'm hoping you could understand a results section like this. There were some problems with this results section. So let's actually start. They have a table in here, don't they? So the first paragraph. They make a statement. The active intervention in educational film groups did not differ at baseline in demographic characteristics and so forth. Notice what they put in parentheses for the P. Do you see what they have on the fourth or fifth line?
Greater than 0.1.
0.1. Is that a right statement? No. You know what the P should be greater than? It should say 0.05. Now maybe it wasn't and maybe they're lying, but it should say P greater than 0.05.
But don't.
Go ahead.
I'm not sure how I want to word this, what I'm getting at, but I remember somewhere like if something's kind of wrong with your study to make it look like it was more accurate than it was, you change it to like 10 instead of 5.
So it could be, yeah, one-tailed versus two idea here. It could be that way, but yeah, this isn't quite right. We're not sure the motive. What they're trying to show here, let's go back to what they're trying to show. A lot of you looked at table 1. They're referring to table 1 here. They are hoping, can anybody tell me what they were hoping between the yoga group, race, education, and employment, and the film group? What were they trying to show there? That they're similar. You would hope that if you randomly assign people to these two groups, that the groups are the same. Looks like the film group is a little bit more, white than the other group. Any other differences here?
No other.
Yeah, there's no other. But if you look comparing between the two columns, the idea would be those numbers are comparable. So this is not a key test of their hypothesis. This is a test of randomization. So do you know what kind of statistic they would use here? So what would be the right statistic to choose? This is important. Yoga group, film group, what are we looking at there? We got N's. What kind of statistic can we look at N's for? What's the appropriate statistic? "14 people in this group, 20 people in that group." Is that a significant difference? What's the right stat to use? Say again? Yes. Chi-square was the appropriate statistic to do. If you've got N's and frequencies, N's are frequencies, you do a chi-square. So is 29 different than 31? You see that under non-Hispanic white? 29 for the yoga group, 31 for the film group. You would want those numbers to be close. So it's saying there were no significant difference. Chi-square, does this make sense? That's a chi-square statistic. Okay, so we got that. Keep going. And they basically say here, in that first paragraph in the results, there was no difference in attrition. There was no difference in a lot of these things. I don't know why they keep saying 0.1. It makes me think that maybe they got something marginally significant here. Maybe 0.07, so they used 0.1. Look at the last sentence in that first paragraph. Do you see the chi there? Yeah, they have 75. There was no difference in attrition. What should they have put for that p value, where it says p equals 0.71? Should it say p equals 0.71? What should it say there? Nope. If something is non-significant, do you know how you report that? P is greater than 0.5. They should have written P is greater than 0.5 if it's non-significant. So they didn't know how to write their APA. Let's go down to paragraph 2. Attendance. Would we want equal attendance in both groups?
Yes.
Yes. Notice they give the means, 13.7, 13.3. Is there a difference between attendance? Between mean attendance, so is there a difference? F162 equals 0.39, P equals 0.53. If this statement doesn't make you roll over in your grave as a statistician, then nothing would. This is completely and utterly wrong. What did we just learn about statistics and F scores? This F score is what?
Less than 1.
Less than 1. How do we report F score is less than 1?
Just F less than 1.
F less than 1 is on the board. Did they know how to do this? No. And not only did they not know how to do this, but who should be reading this article? Okay, let's look at this journal here. The Journal of Alternative Medicine. Hopefully people who are peer reviewers, do you hope that they know what a t-test is and how to report significance? We would hope so. But what is this showing? Not so much. So if you actually understand what we're covering in here and you read this, you said, shouldn't they report F less than 1, you would know more than whom? Everyone. It doesn't really take a brain scientist. Although I love teaching neuroscience. So this is bad. Not only is this bad here, but think about it. They did an F test. Did they really need to do an ANOVA? How many groups did we have here? 2.
Okay, I was thinking they didn't need to do
They should have just done a t-test. They should have known that. Because if you just have 2 groups, you do a t. I know I showed you how to do an ANOVA, but that was teaching. Who should have caught this? They should have, the reviewers. Hello?
I was going to say they only knew how to work one part of SPSS, but apparently they didn't know how to work that either because...
No. So this is bad. The overall, now it's not a critical flaw. It's still showing we got no differences here, but statistically, I mean, this is part of somebody's dissertation. Now that gets really bad because notice on the bottom it says dissertations. So not only does that mean the reviewers didn't know, but who else didn't know that this is inappropriate?
The people who are actually doing it.
Say again?
The people who are actually doing it.
Well, no, not the people doing it. We trust that graduate students would be incompetent sometimes, but whom?
People that are graduate faculty. Yeah.
The faculty review, the committee members. This is embarrassing. And where was this study done? Oh, just UVA! Oops.
So when we go, if I'm doing a paper and I'm going to research articles, I'm trusting that the articles that I'm using, if they're significant in what I'm researching or doing, that it's okay to use that. Should we be looking?
Should you be
more
looking at this level? There's an answer to that. So the strict answer is yes, look at all the articles like that. But the true answer, if somebody ever asks you to critically review an article, you should be able to do kind of what we're doing here. That's why I chose this particular article, because you've learned some basic stats, and these people apparently don't know this kind of stuff, and neither do anybody above them. So no, you don't necessarily do this. You can look at the research, and if you're asked to do a critical review or just a summary, you can do that. When I was working on my dissertation, I was focused on one particular field. It was reading research, actually, and there were 8 articles that were really, really important for my study. When I read those studies, I was doing this. This is garbage. This is good. This is crap. I think this is reasonable. So if push comes to shove, you should know how to do this. And if you're ever asked to do a critical review or do an article critique, this is a good skill to have. Do you generally do this for most? No. Try to look for journals that are a little more mainstream.
If you put in peer-reviewed articles, you're going to
Generally better, but no, not a guarantee.
This would be considered peer-reviewed.
It would be, not a guarantee. I've read.
Doing this if you were trying to design your own experiment, you would
Yeah.
setup.
And this is, yeah, I mean, so you should have a skill of doing this. We've only done one article on this. We may do one or two more towards the end of things, but yeah, this is incompetent. There's no doubt about it. Although it's not a tragic flaw, they got no significance. They're just not reporting it right. I've seen other articles where they even do a bunch of wrong statistics and they don't know what they're doing, and they don't know, neither do the peer reviewers. This is really a tragedy because their dissertation committee doesn't know this. So, whoops. Okay, and it's not unusual. Let's go to the next column. Participants in the program. So, percentages here. Look down at the next column, like 3/4 of the way down. Do you see where it says more F results? F equals 0.99. P greater than 0.3?
What the heck are they trying to do?
Well, apparently the people who wrote that F didn't know about the previous F, because at least the previous F is a little bit better where they have degrees of freedom. These people didn't choose to write degrees of freedom.
This is all the stuff I highlighted when I was reading it.
Right.
I don't understand what that means.
They're saying the results are non-significant.
No.
P greater than 0.3, it should have been F less, this all should have just been F less than 1, non-significant. So this is poor. The results of their study are still valid. There were no differences, but these people know nothing about statistics. And if this is in my discipline, which it kind of is, this is embarrassing. I mean, this is embarrassing for the authors, but more for the people around the authors. There were no differences. This is very interesting. Then the bottom paragraph, there were no statistically significant differences between these groups. So now they cited it a different way. Oh my God. Look at that. Look at the bottom paragraph. Look at the results there. What probabilities do they get? Look at the p-values. P equals what for the bottom paragraph? Are you seeing where I'm looking? 0.06 and 0.09 are actually what? They're, what do we call that? Marginally significant. Oops. Not only do they not report that in the right way, so we've decided not to have degrees of freedom. Now they're saying this is actually getting worse. So in this case, it was marginally significant. They don't know it. The reviewers don't know it. I wish it was 0.04 so we could just say these people are idiots. But this is bad. You could still, so the question going back of if you were reviewing things, is this still a good control group? Yes, but these people are incompetent, and so is everybody around them.
But that makes me kind of question how thorough everything else was and how much they really.
You could question it. It would be okay to question it. It's probably a very lowly peer-reviewed journal. They say at the end, yes, you could come out with the outcome that the control group is the same, although treatment expectations, not that I know exactly what that is, but scores were not correlated with change over time. You just wonder.
Well, last says treatment expectation scores averaged marginally higher.
And look at, and yeah, I mean, God knows what's going on. And look at page 457. They got what for this? On the 457, second column. What's that?
Are you talking about the grants?
They got a grant for this. Oh my God.
Someone gave them money for this.
Yes, it's a good idea. This is garbage. So if you ever want to do something better than this, it really would not be very difficult. I think at one point, I remember when I was teaching, I didn't do this for the physio class, but Jefferson College, I taught a class in neuroscience, and we were looking at mind-body research and NIH research for CAM research. And I looked at the studies. They don't know anything about statistics. I mean, it's just appalling. So if you ever end up doing something good, it wouldn't take very much to be way above these people in terms of, do a t-test.